In our next video about application of integration, we're going to talk about second moment of area. So in your syllabus, it can be split into 3 different type of questions. You can have your little block with laminar strip dx in the first quadrant, or with your x and your axis on this side and your block on the right hand side. You can have your block centered between the 2 axes. So if it's all on the right hand side, you will call this your A. Your upper and your lower limit will be an A with a little 0 there. And again, you will have your upper and your lower limit A and 0. So it's basically you take the second moment of area is represented by the symbol I. So I will be the area times the distance squared, because to calculate I must calculate the area times the distance squared. And to find the area, I must integrate. And when I integrate the area, so firstly, to find the dA over dx, if I have an area, it's the length times the breadth, but this is in terms of h. If I differentiate x, multiply to the front, minus 1, I'll get my area dA over dx. So if I take the dx to that side and I substitute it into my equation, I'll have b times x squared with reference to dx. So now if I integrate this, I will integrate this with my upper limit and lower limit of a over 0. So if I integrate this will become x with reference to x. Your x will gain a x, divide by 3, so it will be x cubed over 3. Then I submit the a value in, minus submit the 0 value in, and my value of my second moment of area will just become b over a cubed over 3. Now this is if they don't give you any values, then you're just going to have it like this from first principles. If your second example, your little strip is split between over the y-axis, then you're going to have half a on this side and half a on this side. So this a will be a over 2. That a will be minus a over 2, and you'll still have your b value. So this will be your upper and lower limit now, a plus a over 2 and a minus a over 2. The rest is all the same as the first one. You got your dA times your area times your distance square. Substituted in, integrated, substitute in the values, and my basic first principle answer will be 6a squared over 12. So the last type that they can ask you is if it's in a circular form and it is right over the axis like this, then your strip will be dr, because the area for a circle will be pi r squared. So if I differentiate this, I will get dA over dr, take the exponent, multiply to the front, minus 1 from it. So dA over dr is 2 pi r. So if I multiply the r there, then I will get my equation like this. So that's what I'll place instead of my area times my distance square. Now this r times that r will give me 3 of them. You can take the 2 pi out. And now I have to integrate with reference to r. So if I integrate, this becomes r cubed. Cube becomes 4, divide by 4. Substitute in, the big R is my limit, my upper limit to the lower limit, R to 0. Substitute it in and you get a value of pi r to the power 4, divide by 2. And that is the basic structure for second moment of area, where you have to go and calculate it, and it can be any of these 3 forms given to you. So if we look at an example where they put values in, then I see in this example, it is all in the first quadrant there, and the distance there is 8, and the height there is 4. So I'm going to have to calculate the area. So you can either first say area is the distance with reference to dx times the area times the distance square. So this height there will be the b value that I have to substitute the b by 4 with reference to dx and the distance square. and then you can write it like this. You're going to integrate x with reference to dx. So if I have to integrate, so you can either leave the 4 or you can leave it on the outside 4. This will become x cubed over 3. And now you need your upper and your lower limit. That would be your 8 and your 0. So there would have been your 8 and your 0. So you'll write your 8 and your 0 there, because it goes from 8 to 0. So now I'm going to substitute the value of 8 in. So I'll have 8 to the power 3 over 3 minus 0 to the power 3 over 3. And if I calculate that, it's going to give me an answer of 682.667, and this was centimeter to the power of 4 for this little application of integration with reference to second moment of area. In the second part, we're going to talk about moment of inertia. This is the same as moment of area, but it's got in terms of mass, which is normally kilogram. So moment of inertia is also represented by the term I equals the mass times the distance square, where second moment of area was area times distance square. So if I have the same lamina there, they will always say the mass of the strip divided by the area of the strip is proportional equal to the mass, total mass over the total area. So if I rewrite this down as the delta M over delta M over delta A, the total mass. So if they do give me the value of how heavy that item is, or the kilogram, I can put in the mass there. And the total area of this strip is A times B, so you'll just write it A times B. And now if I take this dA to this side, that means this must be, I must find the integrate or the differentiated value of this. So if I say dA, it's the same as the previous one, I'll have B dx. So I'm going to substitute this by B dx. Then this B and this B cancel out. So now I'll just have the M over the A with reference to dx. So this will be my mass now that I have to put in. So moment of inertia is the mass times the distance square. And for this equation, it's the mass divided by the distance A there. So I write it in mass the distance A. But because there's no x involved, I have to, only the distance square is x squared. So now if I integrate this, I'll still have my mass over my area. If I integrate this, I'll get x cubed over 3. And I have to substitute the A value in and the 0 in. And now if I substitute this, I'll get M over A. And I'll have A cubed over 3. And now one of these minus 0, so that term will fall away. So this will then just be, this 1A will cancel with that A. So you'll have the mass times the A square over 3. And this will be in units to the exponent of 4 when you're going to do the actual calculation. So this is like the skeleton calculation without values in. So now in your next one, you can just put in your own values.